Section 10.2, the statistics capstone. That's not normal. Looking at standard deviation. This video will help you understand the normal curve, calculate a standard deviation, and include standard deviation in the description of data sets. Let's take a look at our project here. First project here. The third teacher in section 10.1 had no standout students. The third teacher described it in this way. Teacher number 3. My students were all over the place. There were no standouts in this semester. Okay, maybe a few, but not a lot. Here are their scores. And you can see that we get this nice kind of distribution of scores kind of all surrounding this middle group of 70s here. Scores of 70s. So some above, some below. The picture of this group is given at the right. So we have a picture of the graph of this on the calculator there. As stated before, the shape of this group is considered symmetric since the data looks the same on the left and the right. Therefore, the data is not skewed left nor skewed right. A symmetric data set like this one is often referred to as a normal distribution. A normal distribution is also referred to as a normal curve, or sometimes you'll hear it called a bell curve. In a normal curve, most of the data is found in the middle of the graph, with the peak of the data occurring at the average. Many populations of data can be explained with a normal curve. This normal curve represents 100% of the data. The numbers at the bottom of the graph indicate how many standard deviations away from the center the data is. Let's take a look at that now. So this was the graph on the calculator up here, and if we take a look down here, this is a standard normal curve or a standard normal distribution, or sometimes you'll hear it referred to as the bell curve. And so right here in the center we have our average, and the average is also the peak of our graph. Now what a standard deviation does is it measures how far away a piece of data is from the center of the graph. And since groups of data can be spread out over a wide range or narrowly spread out, the standard deviation will change, or kind of is a measure that shows us how spread out the data is. So when we calculate a standard deviation, it's telling us, is this data really spread out, or is this data narrowly packed together? Either way, once we figure out what the standard deviation is, if we have a normal or bell curve, this is the way the data will fall. Right here at the average, and if we go one standard deviation above the average, 34% of all the data will fall within this one standard deviation above. And vice versa, if we go below the average here, 34% of all the data will fall between 0, the average, and 1 standard deviation away from that data. So this standard deviation value can change. It's not always the same. It will change depending upon our data, because again, if the data is really spread out, we'll have a larger standard deviation. If the data is really closely packed together, we'll have a smaller standard deviation. But once we calculate that standard deviation, this is how the data will kind of fall out if we have a normal distribution. Let's take a look now at an example here. Use the graph above and addition or subtraction to answer each of the questions. And let's go ahead and let's have you go ahead and try to answer these questions as we go here. I'll follow up with you in the video, but I think we're ready to answer some of these questions. So what is the total percentage to the right of 0, our average? So if we look at our graph here, what's the total percentage to the right? Then what's the total percentage to the left of 0? And then finally question C, what is the total percentage of data that falls between 1 standard deviation below and 1 standard deviation above? Go ahead and pause your video player now for a second and answer these questions. All right, well hopefully you came up with these answers. So what is the total percentage to the right? Well, if this is exactly in the middle and this is splitting the data in half, we're going to have 50% over here to the right. And what percentage to the left? Same again, 50% of the data, or 50% of the data will fall to the left of our average in the center there. And now the total percentage between 1 standard deviation below and 1 standard deviation above the mean is going to be 68%. All right. The number 0 is placed in the middle of the graph and represents the center of the population, the average. Data found here is the norm or most normal student score on a test. As you found in questions A and B above, 50% of the population is above the norm and 50% of the population is below the norm. Also notice that the largest percentage of the population is within 1 standard deviation below and 1 standard deviation above the norm. The numbers along the horizontal axis, -3, -2, -1, and 1, 2, 3, are standard deviations. Standard deviations are used to measure how spread out a data set is and to measure how close a piece of data is to the norm. Statisticians and scientists often encounter a normal distribution when they study populations. It's just kind of the way things happen. It's kind of a naturally occurring spread of data, this normal curve. When a distribution is normal, roughly 68% of the population falls between 1 standard deviation above and 1 standard deviation below the average. And that's what we calculated in question C above. And is considered the normal part of the population. So 1 standard deviation below to 1 standard deviation above, that is considered the normal part of the population. This means that being more than 1 standard deviation above or 1 standard deviation below the norm is considered improbable or not normal. Okay, let's answer this question now. Use the graph above and addition and subtraction to answer each of these questions. And I think, again, we can answer these questions as we go here. What is the total percentage to the right of 1 standard deviation above? What is the total percentage to the left of 2 standard deviations below? And what is the total percentage that is not between 1 above and 1 below? So go ahead and look at that graph above and then answer these questions. All right, well, let's see. What is the total percentage to the right of 1? Well, let's look back up here at our graph. Total percentage to the right of 1, we're going to add 13.5 and 2.5 there. So that's going to be 16%. So hopefully you came up with 16% for question 1. What is the total percentage to the left of 2 standard deviations below? Let's see, if we look at 2 standard deviations below, to the left of that is going to be 2.5%. What is the total percentage that is not between 1 and -1? Well, we already calculated that between 1 standard deviation below and 1 standard deviation above, that was 68%. So if we take 100%, all the data, and subtract 68 from it, that will leave us with 32% of the data that's falling outside of 1 standard deviation below and 1 standard deviation above. Let's take a look at our second project here now. We're going to look at the data from Teacher 3 students to see how many were normal and how many were outside of that boundary. We will be computing a standard deviation and then making a picture of what that represents. Let's take a look at this example now. And again, I think we can answer some of these questions as we go. Find the average of this set of data. So go ahead now, pause your video player, and let's find that average. Okay, hopefully you calculated that average. You came up with 72.5. That's not a percentage, that's a score, right? So the average score on this test was 72.5. Now what we're going to do is we're going to fill in this chart down here in 4. And that chart then is going to help us find the standard deviation. So what we're going to first do is we're looking at all the scores in this Teacher 3's group. So these are all the scores for Teacher 3's group here. And we're going to use this same average every time we're making these computations here. So always the average here, which we calculated to be 72.5. So the first thing we're going to do is we're going to find the absolute value of the difference. So our differences here, we don't worry ourselves with whether these things are a positive or negative value. We always take the absolute value of this to find and make them all positive. So notice, even though this first score of 55 was below 72.5, the difference we're considering to be a positive value, 17.5. Okay, so finding that difference, and then we're going to square that difference. And again, Next student that scored 60, they were 12.5 away from the average. Square it, we get this. So why don't you go ahead now and pause your video player and complete these calculations here. And when you're done, hit play. See how you did. Okay, so let's take a look at some of the solutions we got down here. Go ahead and check your answers against these answers I have posted here. Okay, the scores are the individual grades for each of the 10 students. The second column is the average. All of these values will be the same since the average is for the entire class. We already talked about that. Third column is the absolute difference, the absolute value difference from the range. To get the value in each cell, subtract the score from the average, then take the absolute value. And remember that taking the absolute value will always make these numbers positive. The fourth column will be made by taking the values from the third column and squaring them. To square a number, multiply the number by itself or use the square key on your calculator. Okay? So we filled the stuff in just like we talked about, and there are values and scores that I just had posted on the other side. Now we're going to use these values from this table now, in fact these values right here, to now calculate the standard deviation for this group of data. So the next step in calculating this is to add up all the squared differences. So that's what we have. This column right here is the squared differences. So we're going to add those all up. And then we're going to take the value in 5 and divide it by one number fewer than the number of items in the data set. So this is almost like finding the average itself, where we added them all up and divided by the number of values. Except with a standard deviation, we add them up and divide by one number less than the number of items in our data set. For example, there are 10 students in this data set. Therefore, we are going to divide that value in number 5 here by 9, one less than 10. So go ahead and pause your video player now and answer these two questions. Okay, and when we add those all up, we are going to get 1,262.5. Now, when we divide that by 9, we are going to get 140.2 with a 7 repeating on the end. So we could round that to 104.28 then, if we rounded that guy out. Okay, question 7 now. Now we are going to take the square root of that value that we have in 6. Once we take the square root here, then we are going to have the standard deviation. So go ahead and take the square root of 140.27 repeating, or 140.28, and we will get approximately 11.84. So that is our standard deviation for this data set. So notice how we calculated the standard deviation again. Let's review this. First thing we did was we filled in this table above here. And the reason we were doing this table was to get this last column here. The differences squared here. So we take all these differences, square them up, add those all up, divide by one fewer than the data set here, and then take the square root of that to get our standard deviation. That's how we calculate a standard deviation for any data set. Okay, coming down here. This answer for number 7 is the standard deviation. This tells you that this amount above and below the average is considered to be normal for this test. People beyond 1 standard deviation above and 1 standard deviation below are not considered normal for this test that the students took. Now that we know the average and the standard deviation, we can put it into the graph to convey what is normal and what is not. Write the average at the center and label this 0, since it is 0 standard deviations away from the mean, or the average, and that's what we've already got right there. Now take the standard deviation, 11.84, and add it to that average. This mark is 1 standard deviation above the norm. If you do it again, you get 2 standard deviations above the norm. Repeat this process with subtraction to get the left side as well. So go ahead and pause your video player. We're filling in these values, these standard deviations here. Okay, so if you did this correctly, we should be coming up with above 11.84 and 23.68 standard deviations to the right, and the standard deviations to the left. One would be negative 11.84, 2 standard deviations would be negative 23.68. Now what we want to do is we want to translate these values into actual test values. So notice instead of having 0 here in the center of our graph, we have the average test score. Because somebody looking at our data set here, or looking at the graph of this data set, they want to get as much information about the data as they can from this picture, this graph that we're making here. This would tell us a lot of information about standard deviations, but it wouldn't tell the reader of our graph a whole lot about what was happening on this test. But it will if we actually put the values in here. So notice instead of 0, as 0 standard deviations above or below, we go ahead and we write the average in there, which was 72.5. And now from here, we use our 11.84, adding it to 72.5 to get 2 standard deviations above, and then subtracting it to get 2 standard deviations below. Then we have our normal curve here with actual test information and test data on it, which would tell our reader more things. So go ahead, pause your video player now and fill in the actual values for this test. Okay, if you did that correctly, here are the values we should be getting. 72.5 in the middle, 1 standard deviation above would be 84.34, 2 standard deviations above 96.18, 1 below 60.66, 2 below 48.82. Let's take a look at question 8 now. Answer the following questions according to the picture on the graph on the previous page. What score was 1 standard deviation above the norm? And if we look back at our graph there, we see that it was 84.34. What score was 1 standard deviation below the norm? So that was 60.66. So according to these answers, this 84.34 and 66.66, anyone in the class who scored between them is considered a normal score for this particular test. Anything above answer A or below answer B is considered abnormal. So now we're going to go ahead and practice one of these things. So we're going to do all of this stuff in one shot here. So here's our set of data, and we're looking at video game console. This is the price of a video game consoles. And so here are the prices. Looks like we've got 1, 2, 3, 4, 5, 6, 7 pieces of data. So you want to calculate first the mean. Then we want to get our deviation from the mean. This is the absolute value difference in this column. Then we square that deviation from the mean, that difference. Square that to get these values. Take the sum of those values. That gives us the sum here. Divide by n minus 1. Remember, n is the number of data pieces we have. So n minus 1 would be 1 fewer than the number of data we have here. Then we take the square root, which will tell us the standard deviation. Once you figure out that standard deviation, go ahead and put your average score here, and then the standard deviations above and below that average, so we get a nice normal graph here, a nice normal bell curve graph. So go ahead now, pause your video player, and calculate the standard deviation here, and then create a normal bell curve graph. When you're done, hit play to see how you did. Okay, let's take a look at some solutions here. So first of all, we calculate the average, or the mean, which was 250. Then we calculate the derivation, or deviation from the mean. All this is the absolute value of the difference. So this is 0, 100, 100, 150, 250, 50, and 150. Now what we're going to do is we're going to square these deviations here, these differences. And so we get 0, 10,000, 10,000, 72,500, 62,500, 2,500, 22,500. Then we're going to add all of those values up to get 130,000. Divide by n minus 1, which in this case would be 6, since we had 7 pieces of data. So divide by 6, and we get this 21,666.6 repeating. Now we want to take the square root of that, which gives us 147.2. So that is our standard deviation right there, and that's what this little s stands for. We use s, small s, for standard deviation. So down on our graph, we should have our average or mean in the center, which is 250. And then by adding successive standard deviations, we get 1 standard deviation above, 2 standard deviations above, 397.2, 544.41, and then standard deviations below, 102.8, and then negative 44.4. You can see that not a lot of data is going to fall right here for video game consoles. Not a lot of people are going to pay you to take the video game console home. So I don't think we're going to find any data down here in the negative range. Okay, so that should get you set up now. The rest are going to be exercises and questions that you're going to answer on your own.